Did scientists just find something on the moon that should not still be there? Because hidden under the lunar surface is a colossal mystery so dense, so misplaced, and so difficult to explain that it is forcing experts to rethink what they thought they knew about our nearest neighbor. And before we dig into this lunar mystery, do me a quick favor. If you love space stories that make you see the universe in a whole new way, tap like, subscribe, and share this video with the one friend who always says the moon is boring. For a long time, the moon felt familiar. It hangs above us almost every night. People have written poems about it, tracked calendars by it, and even walked on it. Out of everything in space, it should feel like the object we understand best after Earth. But the truth is almost the opposite. The more closely we study the moon, the stranger it becomes. What scientists have been looking at is a huge underground mass buried beneath the South Pole Aitken Basin, one of the most extreme scars in the entire solar system. This basin is enormous. It stretches across a huge portion of the moon, and it was created by a violent impact billions of years ago. But the crater itself is not the biggest surprise anymore. The real shock is what appears to be hiding underneath it. Researchers studying precise gravity data found evidence of something unusually dense buried deep below the surface. Not a tiny pocket, not a normal variation, something massive, so massive that it tugs on spacecraft from below like an invisible hand. If you cannot picture that, imagine flying over what looks like an empty desert, while a buried mountain of heavy material far beneath you quietly bends your path. That is the scale of the problem. And this is where the story gets truly gripping. Scientists are not fully sure what the buried mass actually is. One idea says it could be leftover metal from the giant object that slammed into the moon and created the basin in the first place. In that version, part of the impactor did not fully spread out or disappear. Instead, some of its dense core material may have sunk into the lunar interior and stayed there for billions of years, trapped like a fossil from a cosmic crash. Another idea is even more unsettling in a different way. Some researchers think the mass may not be foreign at all. It may be a relic from the moon's own early formation, back when the young moon may have had a global ocean of molten rock. As that molten layer cooled, heavier minerals may have sunk downward and gathered unevenly in certain places. If that is true, then this hidden anomaly is not just a random lump, it is a preserved wound from the moon's violent childhood. Either answer is incredible. One means the moon still carries a buried remnant of a world-shattering impact. The other means its deep interior locked away a record of its earliest evolution and kept it hidden for billions of years. But there is a twist that makes both explanations harder. The mass does not seem to sit exactly where some scientists expect it. Instead of lining up neatly with the center of the basin, it appears offset, shifted, slightly out of place. That detail matters, because when a mystery object is not where the cleanest theory says it should be, the mystery gets deeper fast. Suddenly the simple version no longer works. Now scientists have to explain not only what it is, but why it ended up there. That one detail changes the feeling of the whole discovery. It turns the anomaly from an interesting scientific problem into a nagging puzzle. And in science, those are the puzzles that often lead to the biggest breakthroughs. What makes this even more fascinating is that the moon has a history of hiding strange gravity behavior. Its gravity is not smooth and even everywhere. In several places, it is stronger than expected because of buried dense regions called mass concentrations, or maskins. These are not visible on the surface. You cannot look at the moon and spot them with your eyes, but spacecraft can feel them. Decades ago, when orbiters flew over parts of the moon, their paths shifted in ways that revealed something odd below. Those early hints slowly built into a larger picture. The moon's interior is not as simple as people once assumed. It is lumpy, uneven, full of ancient consequences from impacts and deep geological history. The South Pole Aitken anomaly appears to be one of the most dramatic examples ever found. And that is not just an interesting fact for scientists. It could help explain another modern pattern that has become impossible to ignore. Why does landing on the moon still go wrong so often? That question sounds almost absurd at first. Humans landed on the moon in the 1960s. We send machines across Mars. We can guide spacecraft through deep space with astonishing precision. So why does our own moon still humiliate advanced space programs? Because getting to the moon is not the hard part. Getting down safely is. In recent years, the moon has turned into a brutal test of engineering. Mission after mission has struggled. Some spacecraft never made it to the surface intact. Some crashed during descent. Some landed badly and tipped over. Others lost the ability to judge altitude correctly at the worst possible moment. Different countries, different companies, different designs, but the same unforgiving outcome. That pattern matters. When failures come from one weak team, you blame the team. When failures show up across multiple nations and organizations, you start looking harder at the environment. And the lunar environment is far more hostile than its calm, silent appearance suggests. To understand why, we need to strip away the illusion that the moon is easy just because it is close. The moon has almost no atmosphere. That single fact changes everything. On Mars, even though the atmosphere is thin, engineers can still use it. A spacecraft can plunge into the air, slow down with heat shields and parachutes, and remove a huge amount of speed. On the moon, there is no such help. No drag, no parachute phase, no cushion. A lunar lander has to control its fall with rocket engines almost the entire way down. Think about what that means. A machine falling toward a rocky surface has to calculate its speed, position, angle, and fuel use constantly, then fire its engines at exactly the right times to reduce that motion step by step until it reaches 0 at touchdown. Too fast, and it smashes. Too slow at the wrong time, and it wastes fuel it cannot get back. Too far off course, and it can drift toward unsafe terrain. There is almost no forgiveness in the system. Now add uneven gravity. If a spacecraft descends through a region where hidden mass pulls on it more strongly than expected, even slightly, that can affect the math during the most delicate part of the landing. Not enough to turn a good mission into disaster every time, but enough to complicate guidance, prediction, and timing in ways engineers have to model very carefully. And when the target is near the lunar South Pole, where this giant anomaly is part of the story, the challenge becomes even more serious. This is one reason the moon keeps exposing the difference between spaceflight that looks possible on paper and spaceflight that survives contact with reality. But gravity and lack of atmosphere are only part of it. The moon also forces landers to think for themselves in the final moments. A lot of people imagine ground controllers on Earth steering a lunar lander like a drone. That is not how it works. Signals take time to travel between Earth and the moon. The delay is short on a human scale, but during a landing it is too slow. By the time a human sees a problem and sends back a command, the lander may already be wrecked. So the spacecraft has to rely on its own sensors, its own software, and its own onboard decisions in real time. That means every sensor matters. Every line of code matters. Every assumption matters. If an altitude reading goes wrong, the lander may think it is higher than it is. If the hazard detection system misreads shadows or slopes, it may choose a dangerous spot. If a software parameter is off, a correction burn may come late. These sound like tiny problems until you remember the lander is balancing itself between orbit and impact with no atmosphere and no human hand on the controls. And then there is the terrain. The lunar South Pole is not just difficult because of gravity. It is difficult because it is visually deceptive. The sun stays low near the horizon there, stretching shadows. A shadow can hide a slope, a crater edge from muck or rough ground. A place that looks flat can become dangerous. As for landing systems that depend on optical data, lighting conditions matter a lot. At the pole, the lighting can work against you. So why go there at all? Because the South Pole may hold one of the most valuable resources on the moon, water ice. Inside, permanently shadowed craters, temperatures can stay cold enough for ice to survive for extremely long periods. That matters for obvious reasons. Water supports life. But in space, water is more than something to drink. It can be broken into hydrogen and oxygen. That means fuel. That means breathable oxygen. That means the possibility of turning the moon from a destination into a staging ground. In other words, the toughest place to land may also be the place that matters most for the future of space exploration. And that is what makes the current race so dramatic. Space agencies and private companies are not aiming for the easiest parts of the moon. They are aiming for the parts that could shape humanity's next era in space. The reward is bigger, so the risk is bigger too. Here's the part many people miss. The recent struggles do not mean we are getting worse at spaceflight. In some ways, they may mean we are trying harder missions. Landing near the equator on broad, better lit terrain is one challenge. Attempting precision landings in the South Polar region, where lighting is harsh, terrain is tricky, and the science stakes are high, is a very different challenge. These are not casual repeats of Apollo. They are attempts to solve a harder version of the problem. That does not make failure feel any less painful, but it does make it more understandable. And it also reminds us that Apollo can create a false sense of simplicity in our minds. When people say, we landed humans on the moon more than 50 years ago, so why is this still hard? They usually compress history into a myth. Apollo was extraordinary, but it was not magic. It came after years of failed tests, huge budgets, massive industrial effort, and extraordinary human risk. It also involved astronauts who could make judgment calls during descent in ways robotic systems cannot match. That last part is important. During the first human lunar landing, the crew had to deal with alarms and an unsafe area. A human pilot could look, judge, and steer away from danger. A robotic lander cannot improvise in quite the same way. Unless it has been specifically designed to detect the issue and respond correctly, it is bound by its programming. So when a modern robotic mission fails, it is not proof that engineers today are less capable. Sometimes it is proof that autonomy on another world is one of the hardest things we ask machines to do. If you're still with me, hit that like button like you're locking in a lunar orbit, subscribe for more stories that make science feel like a thriller, and share this with someone who thinks the moon is just a dead rock. Now let us go deeper, because the underground mass and the landing problem may seem like two separate stories, but together they reveal something bigger about the moon. We tend to think of the moon as finished, frozen, geologically quiet, a simple object compared with Earth. But the moon is more like an archive. Its surface and interior preserve events from deep time because so much of it has remained unchanged for ages. Earth erases things. Wind, water, plate tectonics, and life constantly rewrite the surface. The moon is different. It remembers. That means strange structures beneath it can survive for astonishing lengths of time. Ancient impacts can leave signatures that still affect gravity today. Old thermal and chemical patterns may still be detectable. In a strange way, the moon is quiet not because nothing happened there, but because so much happened there and stayed preserved. That is why this buried anomaly matters beyond the headline. It may help answer questions about how the moon formed, how giant impacts behave, and how deep lunar material moved over time. If the mass is from an impactor, it tells us something about how the remains of a colossal collision can sink and survive. If it is native to the moon, it tells us something about how the moon's interior separated and cooled. Either way, the discovery is not just about one weird spot. It is about the moon's hidden history. And hidden history affects future missions in a very practical sense. Every new gravity map improves navigation. Every better model of the lunar interior helps engineers predict how spacecraft will move. Every failed landing adds data. That is the painful truth of exploration. Success gets headlines, but failure often teaches more. When a lander crashes, engineers do not just walk away. They tear the mission apart in data form. They look at timing, sensor performance, engine behavior, software decisions, communication logs, fuel margins, and terrain. Those lessons get folded into the next design. This cycle is not new. Early lunar exploration involved failure. That is the part history often edits out. We remember the triumphant moments and compress the messy learning process. But the learning process is the real story of exploration. It is rarely elegant, it is usually expensive, and it is almost always written in setbacks before it becomes written in victories. The moon is putting us through that again. And that may be exactly what needs to happen if humanity is serious about building a presence beyond Earth. Because a sustainable future on the moon will not be built by one symbolic landing. It will be built by routine landings, safe landings, repeated landings, cargo landings, precision landings near useful resources, missions that do not just arrive once, but arrive again and again until the extraordinary becomes normal. We are not there yet. But we may be watching the hard beginning of that transition right now. That is one reason this is exciting. We are not only watching isolated attempts, we are watching a whole ecosystem of lunar ambition take shape. Governments want science, prestige, and strategic advantage. Private companies want to prove new capabilities. Future planners want ice, infrastructure, and momentum. And all of them are running into the same teacher. The moon, cold, airless, silent, full of ancient traps. There is something almost poetic about that. For centuries, the moon was a symbol, a light in the sky, a canvas for myths, a destination in dreams. Now that we are seriously trying to use it, the moon is revealing itself not as a simple stepping stone, but as a demanding world with rules that do not care about our excitement. And still, we keep going back. That says something important about human curiosity. We are drawn to places that resist us, especially when they promise answers. The South Pole promises answers about water. The buried mass promises answers about the moon's interior. The basin itself promises answers about giant impacts in the early solar system. In a single region, you have mystery, utility, danger, and opportunity stacked on top of each other. No wonder so many missions are heading there, and no wonder so many people are watching. But let us pause on one uncomfortable thought. What if the most important thing about this mass is what it reveals about how much we still do not know? That idea should humble us. The moon is not some distant exoplanet hidden behind layers of indirect evidence. It is our nearest cosmic neighbor. We have mapped it, orbited it, landed on it, and brought pieces back to Earth. And yet, a major structure deep beneath one of its biggest basins can still surprise us. That is not a failure of science. It is a sign of how deep reality goes. The better our tools get, the more layers appear. Gravity data becomes more precise, and suddenly there is a buried anomaly. Landing systems become more ambitious. Suddenly the moon's terrain and gravity quirks matter in new ways. Each technical improvement does not end the mystery. It reveals the next one. That is one reason space exploration remains so compelling. It is not just about confirming suspicions. It is about being corrected by reality. And the moon has a way of correcting us fast. We assume it is easy because it is close. The moon says no, we assume it is simple because it is old. The moon says no, we assume past success means current success should be automatic. The moon says no again. What it offers instead is a bargain. If you want answers, you must earn them. That is true for scientists. It is true for engineers trying to land near the South Pole. And it is true for any nation or company. Nothing about this frontier is free. That is why every detail matters, including the buried anomaly itself. A giant hidden mass beneath the target region is not just a cool science fact. It can shape orbital behavior. It can influence navigation models. It can complicate landing profiles. It can force mission planners to ask better questions. A discovery like this radiates outward. It changes science, it changes engineering, it changes strategy, and it changes the emotional story too. Because suddenly the moon is not only a place we want to visit, it becomes a place that still has the power to surprise us. That surprise matters. Wonder matters. In a time when people act as if every discovery happened in the past, moments like this remind us of unopened doors. One of those doors may be buried under the lunar crust right now. And think about the timing. Just as humanity is preparing a new wave of missions, we uncover evidence of something enormous beneath the surface. It feels almost cinematic, like the moon waited until we started coming back before showing us why not to underestimate it. Of course, science is not a movie. The answer may turn out to be technical rather than dramatic. Better models may narrow the options. New data may show the anomaly is explained by dense mantle material. That is how real science usually works. The final truth is often more precise than sensational. But precise is not boring. A buried relic from a primordial impact would be extraordinary. A preserved concentration from an early magma ocean, too. Either way, the moon becomes richer as a story. And for explorers, the practical reality remains the same. The more we understand, the better our chances of succeeding there. When you hear about a failed mission, ask what was learned. Did a sensor design prove too fragile? Did software need stronger safeguards? Did descent logic need more margin? Did terrain modeling need improvement? Those lessons are the real cargo, and slowly, lesson by lesson, they accumulate. That is how exploration matures, not in one leap, but through repeated contact with difficulty. If this story has pulled you in, subscribe now and share your thoughts. Share this video so more people can see why the moon may be stranger than any of us were taught. Now imagine the next few years, more orbiters refine the gravity field, more landers attempt the South Pole, better instruments scan beneath the crust. New samples may eventually come back. Each mission adds a small piece. Maybe one spacecraft confirms the anomaly's shape. Maybe another reveals structures that point to a specific origin. Maybe a future drilling effort transforms this from an inference into direct evidence. That is how mysteries end, not with one dramatic reveal, but with a chain of clues. Before that clarity arrives, we live in the exciting phase, the phase where the answer is not settled yet. And uncertainty is powerful. It makes people pay attention. It sharpens questions. It pushes science forward. It keeps the story alive because every new piece of evidence matters. A better gravity model is not just a technical update. It is a potential turning point. A safer landing is an engineering win. It is proof that we are learning how to operate in one of the most punishing environments close to Earth. That is why the buried mass and the crash problem belong together. Both are reminders that the moon is active, not through weather or life, but through the consequences it imposes, through gravity, terrain, and preserved violence. The moon shapes what we can do there by what it still contains. And maybe that is the deepest point of all. The moon is not empty. Even where it looks empty, it is not. Its shadows contain ice. Its basins contain history. Its gravity contains clues. Its deep interior contains structures we are still struggling to understand. And its surface contains the next test for anyone bold enough to aim for it. That should change how we look up. The moon is not just a bright circle. It is a layered world, a difficult world, a world with a memory, a world that still has the ability to embarrass us, teach us, and prepare us for journeys even farther away. If we cannot learn to land reliably on the moon's hardest terrain, how will we build bases there? How will we mine resources there? How will we test the systems needed for Mars? The moon is a proving ground, and proving grounds are supposed to be hard. So maybe the recent failures are not signs of defeat. Maybe they are signs that the real work has begun. The glamorous phase of planting flags is one thing. The difficult phase of building competence is another. The moon does not care about our slogans. It responds to precision. That is why this hidden mass matters so much symbolically. It is the perfect metaphor for the moon itself. Something enormous is sitting beneath the surface, and until we understand it, we do not fully understand the world above. That is true scientifically, operationally, and emotionally. The story is that the moon still has secrets that should thrill us and make us cautious. Every future mission will carry both hope and risk. Hope that we will unlock water and create a foothold. Risk that the moon will once again punish overconfidence. We are no longer asking if the moon matters. We are learning how much it matters and how hard it is. The most surprising part is that all of this can be triggered by a discovery we cannot even see directly. Just a hidden concentration of mass, detected through gravity, rewriting how we think about the challenge of working there. That is science at its best. Invisible evidence leading to visible consequences. It shapes the future of exploration. So the next time someone says the moon is a solved problem, remember the buried anomaly and the landers that struggled. Remember the ice, the strange gravity, the brutal descents, and the truth that the closest world can catch us off guard. That is not disappointing. It is extraordinary. It means the moon is not finished as a mystery or teacher. In many ways, it may just be beginning again. If you want more stories like this, subscribe right now. What scientists found on the moon may be metal from an impact or a record of its birth. Whatever the final answer is, the moon is stranger than it looks, closer than deep space, yet harder than we allow, familiar in the sky, but still foreign. Beneath that pale surface, something heavy is waiting for us to understand it. Maybe that is why it matters. It proves we are still asking real questions that force better science and humility. Those are the questions that move civilization forward. Subscribe now if you love impossible questions. Scientists found something unusual on the moon, but the bigger story is what that discovery is doing to us. It is making us look harder, think deeper, and return with more care. That is how the next era is built. Not on certainty, but on curiosity disciplined by reality. Not on hype, but on repeated learning. Not on the idea that it is easy, but on the understanding that it never was. This mystery is powerful. Hidden there is a challenge, a warning, and a record of violence from deep time. And an invitation. An invitation to keep exploring and failing smarter. That is why this story is not over. The next mission will matter. Next time you see the moon, you may see a world with unfinished business.